Hello from Age Educational Academy. So we were doing important questions from all the chapters. So we have completed some questions from application of trigonometry. Let us move on to the next question. Question number 6 according to textbook. So sixth question. As I said, it is not necessary that the questions will be asked with the same numbers. However, similar manner questions are important. Tower and building questions are quite important. So many similar questions are there. So in this question so far what I have understood is you will have difficulty in understanding the height of the tower and height of the building. Like for example, this question is given: the angle of elevation of top of the building from foot of the tower is 30 degree. Top of the building from foot of the tower is 30 degree, and angle of elevation of top of the tower from foot of the building is 60 degree. One of the angle is 30 degree, one of the angle is 60 degrees. If the tower is 30 meter high, find the height of the building. Tower height is given, we have to find the height of the building. This is actually quite easy. You just have to draw a building and draw a tower and get the angle of elevation of tower, foot of the tower, top of the building, top of the tower, foot of the building. But you'll get confused while drawing the diagram. Which of the structure is taller? Is building taller than tower, or is tower taller than building? There you will get confused. So in order to get a clarification over there, what my suggestion is, first of all you draw two same size lines, and represent this as, for example, let us consider that this is a building, this is the tower. One of that is a building, one of that is a tower. Now wheresoever the angle, now here angle is given, the angle of elevation top of the building from foot of the tower, top of the building from foot of the tower. Read it properly. The angle of elevation of top of the building from foot of the tower is 30 degree. Write 30 over here. Do not write exactly here, just keep it there. Write 30. Where exactly you should get 30, write it over there. Next, read it even further. What is it? And the angle of elevation top of the tower from foot of the building. Top of the tower from foot of the building is 60 degrees. Top of the tower, foot of the building is 60 degrees. Now, where is the angle more? Where is the angle more? 30 or 60 or 30? 60 is more. From here to here it is 60 degree, which means tower is at a much higher when compared to the building. Where exactly you have the bigger angle? Opposite of that should be the longest one. Suppose if I get 60 here, 30 over here, this I will draw the longer one. So it's up to you, take building here or take tower here or building here, and wherever you take, you just keep the angles. Angle, you read the statement properly. Top of the building, foot of the tower, 30 degree, write 30 here. Top of the tower, foot of the building, 60 degree, write 60 here. Where exactly you have higher one, suppose 60 is higher, and you have to draw the opposite of 60, this line. If you have higher angle here, you have to extend this one a bit longer, right? So by these angles we can conclude that tower is taller than that of the building. Tower is taller. Now draw lines. This is the line, foot of the building, top of the tower. How much is it? 60 degrees. Next, foot of the tower, top of the building, 30 degrees. And he said that height of the building is 30 meter. Yeah, if the tower is 30 meter high, height of the tower is 30 meter. We have to find the height of the building. We have to find. Now let us name it A, B, C, D. I already told you in this application of trigonometry, all you have to do is focus on drawing, how to draw the diagram. From there you can easily get the answer. Drawing is only the concern. Okay. Next, we have to identify two triangles here. What are the two triangles? A, B, C. In A, B, C, what is angle? 60 or 30? 30, because 60 is divided into two parts and 90 degree. 60 is the 90 degree. 90 degree we won't consider. So in A, B, C, this triangle, 30 is the angle, and one of the side is AB, another side is BC. In the next triangle, what is another triangle? DBC or DCB, whatever, this triangle. In this triangle, what is the angle? 60 degree is the angle. One of the side is 30, another side is BC. Okay, we are not considering hypotenuse, we are considering adjacent in both the cases, because adjacent in same. BC is coming in first triangle, BC is coming in second triangle as well. In the first triangle, which one? DBC. In this triangle, we will take 60 degrees, 30 meter, and we will find the BC. That BC will be utilized in ABC. We can find this AB. Clear? So AB is the height of the tower, DC is the AB is the height of the building, DC is the height of the tower, right? In triangle, first of all, what is this triangle? DBC. In triangle DBC, angle is 60 degrees. Two sides, one of the side is known, one of the side is unknown. What is the known side? Opposite. This 30 is known. BC is unknown. Adjacent. Opposite by adjacent. Tan theta we can take. Tan theta. Tan theta is equal to opposite by adjacent. Opposite by adjacent. What is the theta? How much is the angle? 60. Tan 60. Tan 60 is equal to opposite 30 by adjacent BC. BC is not required, BC is not asked. However, in order to calculate AB, we are finding BC, so that in second triangle it will be useful. Tan 60 how much? Root 3. Root 3 is equal to 30 by BC. If I cross multiply, BC is equal to 30 by root 3. As I already told you, we are not supposed to leave the root in the denominator. However, this is not the final answer. So you can put it there. This will be substituted in some other value. So we can put BC like this only. Next, what's another triangle? In triangle ABC. In triangle ABC. What is the angle here? 30 degree. 30 is the angle. With respect to 30, one of the side, unknown side is opposite. Now BC is already known. BC is 30 root 3. Sorry, 30 by root 3. Opposite by adjacent. Opposite by adjacent is again tan theta. We can use tan theta. Tan theta is equal to opposite by adjacent. Opposite by adjacent. How much is the angle now? 30. Tan 30. Tan 30 is equal to opposite AB. That is what we have to find. By adjacent BC, which is 30 divided by root 3. Do not get confused over here. 30 by root 3. What is the value of tan 30? 1 by root 3. 1 by root 3 is equal to AB by 30 by root 3. Right? So now this entire fraction which is there in the denominator, 30 by root 3, I am sending it over here. It will become multiplication. Root 3 by 30. So if you get confused, you can do it this way. AB by 1 divided by 30 by root 3. AB by 1, A by B by C by D. This fraction 30 by root 3 is complete. In the denominator, in B by 1 is missing. So that's why if I do a reciprocal here, it will become AB by 1 into root 3 by 30. On the left hand side only this is. On the left hand side only. If I send this term to right hand side, it will become 30 by reciprocal of it, 30 by root 3. So just if you do not understand this, do one thing. This entire fraction which is division, I am sending it over here. Same to same fraction. Here now AB divided by, it is in divided division here. If I send it, it will become multiplication. 30 by root 3, same to same. 30 by root 3, 1 by root 3, 1 by root 3 into 30 by root 3 is equal to AB. This 30 by root 3 which was in division, I sent it here, it will become multiplication. Right, now 1 into 30, 30. AB is equal to 30 by 3, 30 by 3, very good. Root 3 into root 3, root 3 whole square root gets cancelled, it is 3. So AB is, right, AB is equal to 10 meter. Meter only he gave, right? Yeah, 10 meter. If you do not understand it, not a problem here. This is the division term. We are sending it over here. It will become multiplication. Remember that. Reciprocal nahi hota. Right. Question number 7. Next question number 7. Two poles of equal heights are standing opposite to each other on either side of the road, which is 120 feet wide. So for example, let us consider that there is this road. Understand that this is understand in a three-dimensional form. One road is there. A road which is like seems like going inside the board. This road, I will try to show you in a practical way. This is the road, and on the either side on both the sides of the road, two poles are there. Two poles of equal height. In the question here, two poles of equal heights. Two poles are of equal height. One of the pole is standing on one side, another pole is standing on another side of the road. Now let us consider that their heights to be x. Why am I writing both x? Because their heights are equal. Right, now next point, from a point between the road, the angle of elevation top of the tower is 60 degrees and 30 degrees. So from a point on this road, angle of elevation of one of the tower is 60, one of the tower is 30. So it won't be at the center. If it is at center, both the angles will be equal. If it is at center, both the angles will be equal. One of the angle is 30 degree, one of the angle is 60. So you can put a point somewhere over here or here. It's up to you. So let us take, we are observing from this point. Now we have to draw two lines to top of the tower, top of both the towers. One of the angle is 60, one of the angle is 30. One of the angle is 60, the other angle is 30 here. Now where should I put this? Right side, this is 30, or this one is the 30? First one or second one? First one is 30. This here, this one is 30. Wrong. This is 60, because lesser the distance, more the angle. More the distance, lesser the angle. So here it is 30 degree. If you take a point over here, at this point it will become 30, here it will become 60. It's up to you to take any side, right? This is the diagram. Let us name it A, B, C, D, E. Now another information, distance. This length of the road is 120 feet. 120 feet. This is 120 feet wide, right? Now let us try to understand this in a practical way. Get that. Let us consider, right, put it like this. Let us consider this is a road and two equal. This is not seem to be equal, but understand that these two are equal poles standing on either side of the road. On the either side, on both the sides of road, two poles of equal height are standing. From a point on the road, somewhere over here, from this point, two angle of elevation is forming. This is from here to here. If you are looking at the top of the tower, this is the angle of elevation. This is 60 degree. From the same point I am observing at another top of the tower, this is 30 degree. Distance is more, angle is less. Distance is less, angle is more. So now we have to find the heights of the tower. Clear? Now the length of the road, width of the road is 120 feet wide. So it is 120 feet wide. So now I'll tell you one of the example here. See, for example, from A to B, this is point A, this is point B, here this is the point C. From A to B, if I have 100 meters, for example, A to B is 100 meter. A to B is 100 meter. From B to C, I am considering that to be X. This is X. How much will be A to C? 100 minus X. 100 minus X. How did we get that? Total length is 100. We have to get AC. So from total we have to remove BC. Total is 100. We have to remove BC from that. Total is 100. BC is X. 100 minus X. Clear? Total is 120. From here, this point, this is for example D and E. From C to E, let us consider that this is Y. Total is 120. Total is 120. What is DC? 120 minus Y. Total minus this distance we have to remove. So the same way, the total distance between BD, length of the road, is 120 feet. Let us consider that C to D, this is X. For example, this distance is X. What will be this distance BC? 120 minus X. 120 minus X. So in this case, in this question, we have to find the heights of the tower. Height of both the tower. If we get one of the tower, it is equal to the second tower, because both the towers are of equal height. That we have to calculate. And from that point, what is the distance of first tower? What is the distance of second tower? If you X we already took. No, let us take some other variable. Y. Let us put that as Y, and this is also Y. We have to calculate X. X is nothing but the heights of the tower. Y is nothing but the distance from the point to one of the tower. And if we subtract that Y from 120, you will get distance from that point to another tower. Now what are the two triangles that we have to consider in this case? What are the two triangles? EDC is the first triangle. Very good. EDC. Next ABC. These are the two triangles. First of all, I am considering either of that is fine. Let us take EDC first. In triangle EDC, it is not mandatory. You can take the first triangle also. With respect to this 60 degree, one of the side is opposite, another side is adjacent. Opposite by adjacent is tan theta. Tan theta is equal to opposite by adjacent. Theta, how much is the angle? 60. Tan 60. Tan 60 is equal to opposite is x, adjacent is y. X by y. Root 3. Root 3 is equal to x by y. From here x is equal to y root 3. Y is in division. If I send it over here, it will become multiplication. Y into root 3, y root 3. Its value is x. X is equal to y root 3. This is the first triangle. Let us go to the other triangle. And what is the second triangle? In triangle ABC, with respect to 30 degree, one of the side is opposite, other side is adjacent. Opposite by adjacent, again tan theta. Tan theta is equal to opposite by adjacent. How much is the angle? 30. Tan 30 is equal to opposite x by adjacent 120 minus y. Tan 30 1 by root 3. 1 by root 3 is equal to x by 120 minus y. If I cross multiply 120 minus y into 1, 120 minus y. X into root 3, x root 3. Now let us consider that this is equation 1, this is equation 2. Now if I put the value of x, what is the value of x here? Y root 3. In the place of x, if I substitute y, I will get the value of y from this equation. Y is nothing but this distance. If I substitute y over here, I will get x. If I get x and y, those are the only two values that we were finding. So in equation 2, substituting equation 1 value, substitute equation 1 in 2. Substitute equation 1 in 2. What is equation 2? 120 minus y is equal to x. What is the value of x? Y root 3. Instead of x, we are writing y root 3. Y root 3 into root 3. Y root 3 into root 3. 120 minus y on the left hand side is same. In the place of x, we are substituting y root 3. Y root 3 into root 3. Now 120 minus y is equal to, put y like that only, root 3 into root 3, 3. Just now we discussed root 3 into root 3 whole square, square root gets cancelled, you only have 3. 3 into y, 3y. So y root 3 into root 3 is 3y. Clear? No. Minus y, if I transfer that side, it will become plus. 120 is equal to 3y plus y. 3y plus y, 4y. 4y is equal to 120. Y is equal to 120 by 4. 4 ones are 4 threes. Y is equal to 30 meter. Meter? Feet. What is the unit given here? 30 feet. Y is 30 feet. Y we got. Y is the distance from the point to one of the tower. Y is not the final answer. We have to calculate x as well. I am substituting y over here. Substitute y in equation 1. Substitute y in equation 1. What is equation 1? X is equal to y root 3. X is equal to, what is the value of y? 30. 30 root 3. 30 root 3. We have to put root 3 is equal to 1.732. So x is equal to 30 into 1.732. 1.732 into 30. 0, 0, 0, 0. 3 2 is 6, 3 3s are 9, 3 7s are 21, 3 1 is 3 plus 2. 0, 6, 9, 1, 5. So after 1, 2, 3, 1, 2, 3, 51.96. X is equal to 51.96 feet. 51.96 feet. So that's this is the final answer? No. We also have to calculate. We got x. So we'll write it in a statement form. Therefore, length of the towers or height of the tower. Heights of the tower. How much is the height? X. 51.96 feet. Next, distance from the point to both the tower. Distance from point to both the tower. One of the distance is y, which is 30. This distance will be 120 minus y. 120 minus 30. So 120 minus 30, how much? 90. So from the point where from where we are looking to both the towers, one of the tower is at 30 feet distance, another tower is at 90 feet. Therefore, distance from the point to tower, distance from point to towers. How much is the distance? 30, 90. Yeah, question number 8 here. So this question says the angles of elevation of top of the tower from 2 points at a distance 4 meter and 9 meter. The angle of elevation from a tower. So one of the tower is there, a tower is there. From the base of the tower, 2 points are there. 2 points are there. What is the distance? Distance 4 meter and 9 meter. Distance is 4 meter and 9 meter. From one of the point, the distance, this distance is 4 meter. From this point again, another distance is 9 meter. This is 9 meter. Now, two angles are formed. From this point, we are looking at top of the tower. From the another point, as we are looking at the top of the tower. These two angles are complementary. These two angles are complementary. In the previous all the questions, he has given 30, 45, 60, whatever it is. But here the first time he has mentioned this angle complementary. In the third exercise, you must have studied about the complementary angles. Complementary is nothing but sum of two angles is 90 degrees. If sum of two angles is 90 degrees, then two angles are said to be complementary. If sum of two angles is 180 degrees, two angles are said to be supplementary. Remember that. No. So angle, one of the angle, for example, first angle is 1, second angle will be 89. One angle is 2, second angle will be 88. So we have to make sure that sum of these two angles are 90. 60, 30, 90. But we cannot say it might be 1 or 89. How can we decide that is it 60 or 30? We cannot say no. So that's why for that purpose we will take one of the angle to be x. Another angle will be 90 minus x. If one angle is either theta, if the one of the angle is theta, another angle is 90 minus theta. 90 minus theta, because if you add these two, plus x minus x gets cancelled, you will get 90. Right? Plus theta minus theta gets cancelled, you will get 90. You have to make sure that sum of two angles is 90 degree. Why are we doing this? Because he has mentioned that some two angles are complementary. Complementary in the sense adding two angles will give us 90 degree. Clear? Right. So one of the angle is x or theta. Let us take this angle as theta. Another angle is 90 minus theta. The distance, one of the distance is 4 meter, other distance is 9 meter. Now we have to find the height of the tower. This is height of the tower. Let us take as x. Height of the tower as x. Let us name it A, B, C, D. A, B, C, D. What are the two triangles here? A, B, C. A, B, C is one of the triangle and A, B, D. Right? In triangle ABC. In triangle ABC. With respect to this C, x is opposite and 4 is adjacent. Opposite by adjacent. Tan theta, the same thing. Tan theta is equal to opposite by adjacent. Theta, how much is theta here? 90 minus theta. The angle is nothing but 90 minus theta. Tan 90 minus theta. Tan 90 minus theta is equal to opposite is x by adjacent is 4. X by 4. Tan 90 minus theta. In the complementary angles in the third exercise 14.3 you must have studied. That 11.3 it is cot theta. Sin 90 minus theta, cos theta. Cos 90 minus theta, sin theta. Secant 90 minus theta, cosecant theta. Cosecant 90 minus theta, secant theta. Tan 90 minus theta, cot theta. Cot 90 minus theta, tan theta. These are complementary angles. Right. So tan 90 minus theta is nothing but cot theta. This is the direct formula. Cot 90. This is cot theta. Cot theta is equal to x by 4. X by 4. That is not y. It is 4. Let us put this as equation 1. Next, what is another triangle? In triangle ABD. ABD. With respect to this angle, opposite is x. Adjacent is DC plus CB. The complete is 9 now. Distance is 9. So we can take 9. Opposite by adjacent again tan theta. Tan theta is equal to opposite by adjacent. What is the angle here? Theta only. Tan theta tan theta is equal to opposite x by adjacent 9. Adjacent is 9. So we cannot do anything from here. So let us consider this as equation 2. Now equation 1 and equation 2. Look at equation 1 and equation 2. I am multiplying both the equations. Multiply equation 1 and 2. Why, I'll tell you. Multiply equation 1 and 2. Equation 1 and 2, right. Now in equation 1, to the left hand side I have cot. To equation 2, to the left hand side I have tan. Cot into tan is equal to x by 4 into x by 9. I have to find the value of x now. So I have to get rid of these two trigonometric terms. We have to get rid of tan and cot. Tan and cot should no more be there in the problem. So for that purpose I am writing multiplying cot into tan, cot theta into tan theta. Left hand sides, both the left hand sides of both the equation is multiplied, is equal to x by 4 into x by 9, x by 4 into x by 9. And why did I do this is because I can write tan as 1 by cot, tan 1 by cot, or cot 1 by tan. From there both tan tan or both cot cot will be cancelled. So trigonometric terms will be cancelled. We will only have x, we can find that. So that's why cot can be written as 1 by tan 1 by tan theta into tan theta. 1 by tan theta into tan theta is equal to x into x, x square. X plus x is 2x. X into x is x square. When you are multiplying, power will be increased. When you are adding, coefficient will be increased. So 4 into 9, 4 9s 36. 4 9s are 36. Tan and tan gets cancelled. So here we will have only 1. 1 is equal to x square by 36. 1 is in division. If I send it over here, it will become multiplication. X square is equal to 36. X square is equal to 36. X is equal to root 36. X is equal to 6, what is meter, right, 6 meter. Actually it will be plus or minus. Once we remove the root, I already told you it will be plus or minus, but distance and heights cannot be negative. That's why we are neglecting the minus and directly taking the plus value. It is 6. Clear?